Welcome to 12.3. In this section we're going to be talking about inscribed angles. The objective is to find the measure of an inscribed angle and the measure of an angle formed by a tangent and a chord. So we already know what a tangent is. We talked about that in 12.1. But a new one we have is a chord is a segment whose endpoints are on the circle. And then another definition we have is an angle whose vertex is on the circle and whose sides are chords of the circle is called an inscribed angle. So angle C is inscribed in circle M, and that's because C itself is on the circle here, and then the two lines are going to be chords. These two are example of chords because they're in the circle and they go from one point of the circle to a different point. And an arc with its endpoints on the sides of an inscribed circle is an intercepted arc. Okay, so UV is the arc, and it is the intercepted arc of inscribed angle T, because T goes from U to V. So here's my intercepted arc there. Theorem 12.11, inscribed angle theorem. The measure of an inscribed angle is half of the measure of its intercepted arc. So if we've got this circle over here, and we've got B, which is this angle right here, it is going to be half of the measure of AC. Okay, so if I know what AC is, I can take half of that and get angle B. So this first example here, what are the values of A and B? Well, if you look at it here, A goes from P to T, this angle right here. Now if you look, I have a chord here and a chord here going from to P and to T with this 60-degree angle. Well, according to the theorem we just had, the angle 60 is going to be half of the measure of the arc. So angle A, or arc A, is going to be 120. And then for finding B here, we've got the two arcs, or the two chords, I'm sorry, going to P to S. Well, if we look here, if we look at the arc going from P to S, we know A is 120, and we know this one down here is 30. These two combine to get 150. So the arc that B, the inscribed angle, is for is 150. So B is going to be half of that, 75. So now go ahead and try part B here. Pause the video, do the work, and then when you're ready to go, push play and you can check your answer. Okay, so for this here, X is going to be 22, because if you can see here, X is this angle with the chords going to this 44-degree intercepted angle. Well, X is going to be half of that 44, which gives us 22. Y is the intercepted angle, and the inscribed angle that goes with it is this 54-degree angle, so 54 is going to be half of Y, which is going to give me 108. So there are three corollaries that go along with theorem 10.11. And the first one, corollary 1, two inscribed angles that intercept the same arc are congruent. So if you notice here, we've got inscribed angle A goes here, inscribed angle B is here, but you notice that the endpoints are the same. There's the endpoint for one, there's the endpoint for the other. So if two inscribed angles share those endpoints and share the same arc, then they're going to be congruent. Corollary number 2. An angle inscribed in a semicircle is a right angle. Okay, so if we've got inscribed angle C here, and we notice that it makes a semicircle, that makes our angle for C 90 degrees, which would make sense because this arc is 180, and what's half of 180? 90. So that's going to make it a right angle. Corollary 3 is that the opposite angles of a quadrilateral inscribed in a circle are supplementary. So for the example here, we're going to use angle D, which has these two chords, and we're going to use angle B, which has these two chords. Okay, you'll notice they have the same endpoints, but they don't share the same arc. Angle B has an arc going from A to C, and angle D has an arc going ABC around this way. And if you notice, if you were to combine those two arcs, you would get the full circle. So therefore, the two arcs would add up to 360, and since the inscribed angles are half of the lengths of the arcs, the inscribed angles should add up to 180, making them supplementary. Okay, so a couple examples here. So we're using the corollaries to find the angle measure. For part A, we're looking for angle 1. Now, if you'll notice here, angle 1 goes here. So we're looking for this arc length there. If you'll notice, the line going across goes through the middle of the circle. That makes this a semicircle. And if this is a semicircle, angle 1 is going to be a 90-degree angle. Okay, so that's what we're going to have. Okay, for B, we're looking for angle 2. Okay, so angle 2 has these two for chords. Okay, if you look, this other angle has chords here, and it has a 38-degree angle. They share chords, and they share an arc. That's going to be corollary 1. So angle 2 is going to be 38 degrees. Go ahead and give C a try. We've got 4 angles to find. Pause the video, get your work done, and then go ahead and hit play to see how you did. Alright, so what we have here, angles 1 and 3, if you look at those two, angles 1 is here, and angle 3 is here. They both meet at this line through the middle of the origin, which means they're with semicircles. So they're each going to be 90 degrees as per corollary 2. Now, with angles 4 and 2, and if you notice here, angle 4 goes from here to here and has this arc. Well, we know what this arc is. 60 plus 80 is 140. So if the inscribed angle is half of the arc length, half of 140 is going to be 70. Okay. Then to get angle 2, we're going to use corollary 3. If opposite angles of a quadrilateral inscribed in a circle are supplementary. If you look, here's 2 and here's 4. They share a endpoint with their chords, but they have opposite arcs. Well, if this is 140 over here for 4, for angle 2, this is going to be the rest of it. So that's going to be 220. Well, half of that is going to be 110. Our next theorem is theorem 1212. The measure of an angle formed by a tangent and a chord is half of the measure of the intercepted arc. So if I have this first one over here, I've got chord BC right here, and I've got tangent that meets at C. Okay, this angle over here is going to be half of the arc that's listed there, BDC. Okay, so it's half of that distance. And I can also do that the other way. If I still have BC being the same, and I have my tangent the same, but I want to go the other direction, if I want to go this angle, that is going to be half of the intercepted arc. So I take the other arc and take half of that measure as well. So whatever it is, the measure of C is going to be half of the measure of arc BDC, or the intercepted arc. Okay, so our first example, in our diagram, we've got line SR is tangent to circle Q, or to the circle at Q, and then they give us that PMQ, which is this right here. This distance is 212 degrees. So they want to know the measure of PQR. So they want to know this measure here. So what we're going to do is we're going to use that last theorem, except for there's one slight change we have to make. Okay, this measure is going to be 1/2 of the intercepted arc. I need this arc measure. I don't need the 212 over there. I need what's left. So I can take 360 and subtract the 212 from it, and I'm going to get 148. This is a 148 degree arc. Well, this angle then, measure of PQR, is going to be half of that, half of 148, which is going to get me 74 degrees. Okay, one more time, give this last one a shot. You need to find X, Y, and W. So go ahead and pause the video, get your work done, and then push play to see how you did. Okay, for these we should have gotten that X is a 75 degree angle. Because of that theorem 1212, we've got an intercepted arc of 150. So angle X should be half of that. Half of 150 is 75. We should have gotten that Y is 210 degree arc, because if I have 150 on this bottom part, the rest of the 360 should be on the top. So 360 minus 150 should get me that 210. And then finally W, if I use that last theorem again, if Y is 210, W is half of 210. Half of 210 is 105.